Hello guys, welcome to this video. As we all know that coronavirus has proved to be a major outbreak in our country, so I request you all to please stay safe and please stay at home. So today's video is day 4 of computer vision. As in previous videos, we studied about how to access the webcam of a laptop, how to perform basic image operations with the help of OpenCV, how to detect face with the help of our webcam and a pre-trained classifier. So in today's video, we'll be extending the content of my last video, which was face detection using OpenCV. Today, we'll talk about eyes and smile detection. So in today's video, we'll be again using pre-trained haarcascades, which will be helpful for detecting our eyes and smile in a particular video frame. So smile detection has a lot of applications these days. Smile detection comes under the broad perspective of emotion recognition, feedback recognition, and other applications. Some of the applications of smile detections include media industry, where it is important to recognize the emotions or response of public to their products. Apart from this, there are various gesture-based feedback systems under research, where a customer's feedback is recorded with the help of his speech, his written documentation, along with his face emotions. Face emotion recognition is also a lot more has a lot more hype in various industries. So today we'll be implementing a part of emotion recognition, that is smile detection. So as I said that I would be implementing smile detection with the help of OpenCV haarcascades. So let's jump straight to the code and have a look at it. So here is the code. I have written it earlier. So I will explain you the code so that you can relate more to it and have more practice. So firstly, as we can see that in the line 5 I have imported all the required packages which I would need during my code. Since in this code I need only OpenCV, so I imported the required package CV2. In the next lines, I have loaded all my cascade classifiers into my code so that I can use those classifiers after when I need them. So the face cascade signifies the hair cascade frontal face classifier. The eye cascade signifies the eye classifier, which would be able to recognize our eyes, and the smile cascade signifies the smile classifier, which would be helping to detect my smile. So in the next line I have written a function detect. Basically I have done all the functionality in this detect function. So firstly I have taken that video stream in the while loop, and then so I have written a detect function. I have written all the detect functionality here. I have taken the video stream which is converted into grayscale in this while loop below, and I have then passed that video stream and into the detect multi-scale function, and then I have stored those data in the variable faces. Now the data has come in the form of coordinates. When the face is detected, some coordinates are returned to the variable by the function detect multi-scale. So I have written a for loop where for x, y, w, h in faces. Here x, y, w and h signify the top left coordinates of the face portion, and w and h signify the width and height of the area of the face. So with the help of these we can pass these arguments to cv2.rectangle function so that it will be able to draw a rectangle around my face. After that I have considered some region of interest, as a region of interest was explained by Avinash to you in the previous video as well. So I have done slicing here. I have taken my region of interest through my video so that I can find my, for example, if a face is detected, so in the whole video I'll take that face as my region of interest, and then I'll search for eyes and smile in that region only. So for this purpose I have created this region of interest for grayscale video and region of interest for color video as well. Now I'll have loaded my eye cascade classifier, and then I have passed these required arguments to my function detect multiscale, and then I'm returning those values of eye coordinates to the variable eyes. Again, I have written a for loop similar to the face, where I would be drawing a rectangle around eyes with the help of the coordinates returned. Same I have done for the smile part. I have loaded my smile cascade classifier, and then I have drawn a rectangle around my smile with the help of these coordinates sx, sy, sw and sh. Now since you'd be able to see that cv2.rectangle function here in line 16 has this tuple 255 0, 0. So this tuple basically signifies the BGR values. The first entry of the tuple 255 means that the color would be blue. The second entry of the tuple 255 means that the color of the bounding box or rectangle would be green. So similar I have done, I have kept three different colors for three different things, since in this video we'll be detecting three different things simultaneously, that is a face, eyes and my smile. So I've kept blue for my face, green for my eyes and red for my smile, so that it could be differentiated. So this is all about the detect function, and then we have taken input, and this is a normal while loop where we have written the functionality. We have read the feed with the help of the read function, then we have converted it into grayscale, and then we have called the detect function here in the line 32, and finally we have called cv2.imshow function, where we would be displaying that frame to onto our laptop screen. And lastly I've written a wait key, and the last function cv2 destroy windows is written as usual. So I think we are done with the code. Now let's jump to running this code and having a look at how this runs. So as you can see, this particular thing is detecting my face and eyes along with my drawing a bounding box around my spine. So let me show you this. So as I am smiling, so this is drawing a bounding box around my smile. Let me close this first. So as you saw that it was drawing the red rectangle for smile at times even if I was not smiling. So again that part lies with the accuracy of the model. So since this is a pre-trained model and this is a very traditional model which we have used, so there may be some accuracy issues, but I would like to mention one thing here, that that this particular bounding box is kind of drawn frame wise. So in real world applications we don't take into consideration the frame wise calculations. We usually keep a threshold for frame because they are around 28 to 30 frames per second in a video. So you don't need to analyze each frame in each second. So for example, if our problem is to solve that for how much time a person is smiling, so we don't need to take each frame consideration. We'll keep a threshold and keep the and take that value out of it. So even if it is drawing a rectangle in some frames in which I'm not smiling, that's not an issue actually, because that would be ignored by means of the threshold which we would keep in any real world application. So otherwise its accuracy can be improved if we can train this haarcascade with the help of more data and images. We can improve this accuracy. In fact, more improved versions would have been there on the internet. If you can search and find, that would be a great thing. So this was all about today's video. I hope you must have liked the video. I'm going to do one thing. This particular code is on my GitHub. There's a repository called Smile Detector OpenCV project. So I committed this back in 2019 when I just began with things. So I would be attaching the link for that particular repository below. You can just go to that link, clone that repository, have all the files downloaded to your laptop, and then run the code. And you can do all hands-on things with the code. You can change stuff, you can do a lot of stuff, and you can have those changes with you, and just play with the code. So I would like to end today's video here. So thank you so much for listening, and I hope it was a great video to you people. Any questions for this code, for this particular thing, for this video, related to this video, are humbly welcome, and I would love to address those questions in the comment section below.